All right, so we had a question about uh, interaction effects in class, and I thought I'd go and give you an example of clarifying that and hopefully clarifying a couple of other issues along the way. And so we'll be bouncing back and forth between Stata and Excel, and in the Excel sheet here I've got the results from some Logit regressions and how we calculate the probabilities and how leaving in the interaction effects, which is the top model here, and taking out the main effects here affects our results and why you may or may not want to do that. All right, so bouncing back to Stata, let's go ahead and go to statistics, and we're going to do a binary outcome and then a logistic model, and we'll bounce back and forth between Logistic and Logit. They give us slightly different results. We're going to put our Dow Jones, whether it's up or down, our bond lag, our oil lag, and then whether the volatility is up and whether the oil is up. And so we end up with our model here, and we say okay, and you notice it dumps our results here, and it gives them to us in the, when we run Logistic here, it gives them to us in an odds ratio output, and we'd like to see those in the parameters. There's a couple ways to do that. The easier way, for me anyway, because I'm a lousy typist, is just to change it to Logit, which will then turn those parameters into parameters rather than odds ratio estimates here. And if we go ahead and hit a return, that will give us the same set of variables in the parameters that are the parameters of our Logit equation rather than the exponentials, which are the odds ratios here. So you see that 1.4423 and the 0.36. Well, if we take this 0.36 here, I'm going to copy it. I'm going to bounce over into Excel and just use a square here for a minute. And I'm going to do EXP, put in that value, hit an enter, and you see the 1.4423. Well, if we back up to our Logistic, you'll see that's our 1.423. So you could either do the natural log or these parameters, or you could simply run the Logit. I wanted to show you that that's the difference between the two of those. The Logit puts out the results in the coefficient and values, and the Logistic puts them out as odds ratios. They are the same thing. And the probabilities will be the same, etc. You can verify that for yourself. So this has both of our main effects, meaning whether oil is up and VIX is down, and the interaction, which is the oil up, VIX down. They ran here all together, and in this case we see that when they're all included, only oil up is particularly significant, and we can continue with what we usually do and look at our post-estimation results for classification statistics. We say okay, and we see in this model we have 59% correctly predicted. Yeah, we had a better model in class, but I just wanted to use a reduced set here to make the calculations slightly easier. So not a great model, 60%, but that's okay. But then we want to know what happens okay, and we are going to run this without the main effects, which are the VIX down and the oil up. So we'll go back to our statistics, our binary outcome, our logistic regression, and I'm going to get rid of my VIX down and oil up here, and okay. And I will run it as a Logit again. To get a different set of parameters here. I will run the post estimation and see that our fit dropped a little bit, and you'll see we don't, when we do that, we are missing getting these other values substantially. Even though it appears to fit as well, we don't get the negative values as much here, and our negative predicted values pretty much disappear. It's not nearly as good a model, but I wanted to do the simpler model to do some calculations in Excel. So we have these two sets of parameters, which you'll see over here in Excel, and our coefficients here. You'll see that the coefficients have changed. The constant is somewhat different, and then our interaction effect has become much larger, and again, but our interaction effect has now become extremely significant, the most significant of any of the variables we have. So there may be some interaction effect, or it may just be capturing what's happening in oil. But the next thing I want to do is show you where the probabilities come from in these two models. So let's go ahead and go up here to our J3, which is the probability from the first model. And if we click on that, it is, you can see that it is the constant plus it's the to the exponential of the constant plus the parameter 0.003 times U3, which is the bond lag, plus the coefficient on oil lag times oil lag, plus the coefficient on oil up times oil up, plus VIX down times whether VIX is up or down. All of that over 1 plus that same equation. That's the Logit equation. You can go ahead and look at this. I will put the Excel sheet on Moodle. You can go ahead and look at this, and this is our equation for the Logit, and the Logit is the probability that is the Dow Jones went up on that day, and the one below just simply this follows on down and does for the next day. And then from the emitted model, you'll see we have the constant of the emitted model plus the interaction coefficient times the interaction plus the bond and the oil lags, and the same in our Logit formula, which are also in the class notes. But you can see that full formula here. You can write it out if it helps you remember it, but this is our Logit formula. This is what we're predicting when Stata runs the model. Don't worry about PR6. It's a different model. But we can simply do our probabilities in Excel. Now, if we use the 50% cutoff when we were talking about specificity, we would say predict 0, 1. Well, let me say up, down. Put it in words here. Well, if this is greater than 50%, we would predict the Dow to be up. So we'll do equals J2 greater than, let me do the if J2 or J3 is greater than 0.5, then we're going to put up. Otherwise, down. All right, and we drag that down, and these are all ones where it predicted it to be up. So, not a very good model, but I wanted to show you the formulas here. Now, why would we drop these interaction terms? Just to make a simpler model. It is often considered unwise to do so if we want to get the correct parameters, because in this model, it's the same as if we had put parameter values. If we turn these, just set these values here, if we just said those were 0, so if we did that for just a minute, if I just put 0 in here for VIX down and oil up, then you see we get very different predictions, and it would have predicted everything being down, because these parameters here now are very different than the parameters that remain. So you see how that artificial zero restriction here, which is what this is here, leads to very different parameters. And in general, if these are not exactly zero, then these parameters will be what we call biased, meaning the true parameters, the estimated parameters will never equal the true parameters. So that's why there's a warning against dropping those in statistical estimation. If the model had fit as well, you might want to do that for computational reasons. But that's it. Okay, we could have actually done the interaction effects directly using a Stata command without brute forcing it into our 0, 1 variable there. If we went to statistics, binary outcomes, and our logistic regression, as you will recall, our full model before had VIX down and oil up in it. And we created our oil up VIX down variable, but we could have let Stata do the work here and done VIX down $, which tells us we're going to do an interaction, and oil up. All right, and so we run that, and it gives us the same parameters that we had before. It fills out what's called a contrast matrix, and we can talk about that some more at some point. But it gives us the same model, and again, if we change that to Logit, it gives us our Logit coefficient, and you see that these models are the same here. You can go back up and look at the parameters, and they will be the same. And so we get our identical models here. It puts it out a little differently because this contrast matrix, because these could be more complicated, where these 0, 1s and 1, 1s, they're omitted largely because they would be completely filled out by the oil up and VIX down, completely collinear. But let's see if we can, I'm just going to click the Logit here. What would happen if we just got rid of we just had our interaction effect, and we just got rid of our oil up and VIX down? If we just took them out of our equation altogether in Stata, and we only had our interaction effect, and we hit a return, you see in this case, it builds out the entire model and sticks them back in here, and so we end up with it fills out the full model as if it had been there anyway. It doesn't allow us to do only the interaction without brute forcing it in the way that I did before. And do we end up with the same prediction results here? We're going to go ahead and run that. And we end up with our same 59.76 that we had before. So we end up with the same model, although in a slightly different way. So Stata doesn't even let us run the incomplete model. If we want to run it in an interaction term, it assumes that we want to do that. And the reasons for that go back to papers by Nelder back in 1977, and one by Commenta in 1998, and one by Venables in 1997. I'll put those up on Moodle for those of you who want to look at the linear algebra, but for now I hope I've convinced you that there are pretty good reasons for leaving them in, but it's perfectly statistically possible, and in a model fitting sense, you might want to leave them out. There are a number of situations where we have interaction effects. The Dow Jones itself is an interaction, any effect, and we don't specify the full model, but when we can specify the full model, it gives us some statistical validity that we might want, particularly when we've already used the variables. I hope that clarifies things. If not, come talk to me.